partial fractions. So children, see in numerator, if you have given some factors, so how you can write? See, first was where you have given px plus q upon two factors are given x plus a into x plus b. Then you can write a upon x plus a plus b upon x minus b. Right? Then if suppose three factors are there, then three variables you will use a, b, c. Now, if one variable, one fraction is in square, like this, x minus b. Start with new page. Stretch. See, if fractions are in px plus q upon x minus a whole square into x minus b. Suppose this type of fraction will come. So you will write like this, a upon x minus a, least power you will write, then b upon x minus a whole square plus c upon x minus. Okay. Now, if you have given factors like this, px upon q, x square plus ax square plus bx plus c into x minus a. So this is your quadratic polynomial. So if it cannot be factorized, then you will write like this, ax plus b upon ax square plus bx plus c. Now this is your factor x minus a. So two variables you have introduced. Now you will write capital C upon x minus a. Okay. So suppose if you have given question like this, suppose 2x upon x minus a into x minus b. So you have to write two different denominators are given. So you will write like this, a upon x minus a plus b upon x minus b. Okay. Now your next step will be, children, x minus a into x minus b. And here also on left hand side, x minus a into x minus b. Okay. Now take LCM. When denominators are different, you can just cross multiply. So a into x minus b plus b into x minus a. Now this will cancel. Right? Then 2x will be equal to a into x minus b plus b into x minus a. So what you can do here? We have to find values of a and b. So what you will do here, Dhanunjay? What we will do?
Substitute the value. First substitute the value b and then substitute the value a.
Yes.
You will get that.
We will put value of x as b. Why? Because it will make this term 0 when you are putting b instead of x. So it will be 2b is equal to, this will 0 plus b into b minus a. Then value of capital B will be 2b upon b minus a. This, okay. Now we have to find for b. Now here, b you have find, now you will put x is equal to a. Then 2a will be, now this term will be 0 when you are putting x is equal to a. Then a into a minus b. Then value of a will be 2a upon a minus. Yes, Jaswant? Understood this thing?
Yeah, ma'am.
Okay. Now in next step, what you have to do? You have to just put the values here. Let this is your equationing. Okay. So just put the values of a and b here. So Your integration was 2x upon x minus a, x minus b, dx will be equal to a. A is 2a upon a minus b, and it was given 1 upon x minus a dx plus 2b upon b minus a, constant term, because you will integrate only x terms. Okay. So upon x minus b. Now we know that integration of 1 upon x is equal to log x. So it will be 2a upon a minus b log x minus a plus. Now this is your constant term. So you will write 2b upon b minus a log x minus. Clear, beta? Jaswant Dhanunjay, is it clear, beta?
Yes, ma'am, it's clear.
So children, we have studied till integration without limits. Now we will study the limits, okay? So that is called definite integral. That is called definite integral. So this is first theorem on definite integral, or you can say on calculus. Fundamental theorems of integral calculus. Integral means integration. Okay. So basically it is area function. So we have defined a to b fx dx as the area of the region bounded by the curve. You can take y is equal to fx. Okay. The x-axis and the ordinates. X is equal to a and x is equal to b. So basically, this is a to b fx dx. So when you are integrating, dx is written. It means these are the ordinates. These are called the limits. Limits, lower limit and upper limit. So this is called lower limit. And this is called upper limit. Okay. So here, so let's solve. Let x be any real number. If you are taking x as any real number in closed interval AB. What do you mean by closed interval AB? It will include say or not?
Yes.
Tell me. Tell me, beta, we did now. Obviously, it will include,
Square bracket.
right? Because for closed interval, the value of x will be greater than equal to a, right? And value of less than equal to b. Got it? For closed interval, this is your closed interval,
Yes, ma'am.
right? So suppose So let's suppose this is the curve. Y is equal to fx. Okay. This is your x-axis. This is your y-axis. And ordinates are given A to B. Suppose this is A point and this is B point. So your region will be this. Right? And this shaded region. Now suppose if I'm asking, then suppose there is a point L. This is your point P. This is your point M. This is A and this is B. Okay. So A into X, fx dx represents area of shaded whole. I'm explaining by parts, okay? Step by step. So this area represent area of shaded region AM, this AM, L, and this is your P. AM, L, P. And it is assumed that the function is positive. Function is positive for all x belongs to a closed interval A. Okay. So your area will be, area function of x will be A to x, fx dx, where x is greater than equal to A. So this is the condition. So the definite integral will be, your definite integral, and till partial fraction which we have studied till tomorrow, till yesterday, that is belongs to indefinite integral. Okay. So definite integral, because here we have values of x. A to B fx is the value of area function. Area function means ax at the point x is equal to b. So there is first theorem. So this is the first theorem only of the calculus, that area function is equal to a to x fx dx and your a dash is equal to fx. Okay. Now your second theorem, which is most important, which is always applicable. Second theorem of fundamental. Second fundamental theorem you can write. Fundamental theorem of integral calculus. What is basically? So let f be a continuous function. On the closed interval AB, and phi be any antiderivative. Antiderivative means integrate. After integral, the integration, the value, which value comes. So phi be an antiderivative of f. Then a, b, fx dx. Suppose the value comes after integration phi and the values are phi a to b. This is your lower limit. This is your upper limit. So fundamental theorem says firstly you will put a upper limit minus lower limit. This is the second fundamental theorem.
Ma'am, are we supposed to by heart these both?
Yes, Vita. Now see, I am explaining with the example, then it will be more clear. Suppose you are integrating 1 to 2 x squared dx. So we know that by power rule, x to the power n will be equal to x to the power n plus 1 upon n plus 1 plus c. Right? So here, integration will be x cubed by 3 beta.
Yes, ma'am.
Tell me. Now this is your upper limit and this is your lower limit. So 1 by 3 is constant term. You will write like this. Now write x cube. Instead of x, you will put 2. So write 2 cube minus 1 cube. Is it clear? Upper limit minus lower limit like this. 5b minus 5a. So 1 by 3, 2 cube is 8 minus 1. So answer will be 7 by 3. Got it, beta?
Yes, ma'am.
Suppose that you have to integrate log x. Not log x, 1 upon x. Right? Otherwise, we have to apply the product rule. So 1 upon x, integration of 1 upon x. And you have to integrate from 5 to 6. So integration of 1 upon x is log x and 5 to 6. So firstly, you will put upper limit in place of x. So it will be log 6 minus log 5. Now we have the property log m minus log n and it will be equal to log m upon n. So this will equal to log 6 upon 5. Have you noticed any difference in a definite integral or indefinite?
Yes, ma'am. They are totally different only, ma'am.
How?
Ma'am, here we can find the value of x.
Yes, because here we got the value of integration in terms of numerals, right? And in indefinite in terms of x only, right? And here we are not using any constant of integration c because we are having definite values of x, right, beta?
Yes, ma'am.
Okay. Now try to solve this question, beta, so that I came to know that you have understood this theorem of. So you have to integrate 0 to 1, 3x square plus 2x plus k. Plus 3 we can write. Just wait. Minus 2. Integrated, beta. And tell me value after integrating.
Ma'am, could you please write the formula at the right side?
Yes, I will write. See, a to b fx dx, right? So 5b minus 5a, right, beta? And x to the power n integration is x to the power n plus 1 upon n plus. Anything else, beta?
Yes, ma'am. It's fine. No need.
Okay. Dhananjay, tomorrow I will take your class, beta. Okay.
Which time, ma'am?
I think tomorrow there will be no class now.
Yes, ma'am.
So just tell me at 4 o'clock may I take or 4:30 or this same time only 5:30.
Ma'am, it's your wish.
Okay, then at 5 o'clock may I take?
Yes, ma'am. 40 minutes class, ma'am.
Maybe it will be extended at 6 o'clock.
Okay, ma'am.
You are having any problem?
No, ma'am.
Okay. Okay, then fine.
Yes. Ma'am, I'm getting the answer as x cube plus 2, ma'am.
What? X cube plus?
2.
And put the value of this, these values now.
Ma'am, 3.
Okay, let me check. Because I have not given this question from any book, na? Okay, let me check. So it will be 3x cube by 3 beta. And this
Yes.
will be 2x square by 2 minus 2x. Same integration you have got?
No, ma'am. I took minus 2 as constant and kept 0, ma'am. I went to
No,
different place.
integration of 1 is x, na beta?
Yes, ma'am.
So it will be cancelled. Then x cube plus x square minus 2x.
Yes, ma'am.
Right? So
Yes.
0 to 1. Now put value of 1 first of all. So 1 plus 1 minus 2. Right?
Yes,
Then minus. Put value of x 0. So 0 plus 0 minus 0 beta.
yes, ma'am.
So answer will be 0 only. Right?
Yes, ma'am.
Okay. Now try to solve next question. Now solve. Zero to 1, 2x cube plus 3 whole square dx. Solve it. Firstly, open the identity. Okay, beta?
Ma'am, 88/7. Hello, ma'am.
Dhananjay, done? Am I audible, Dhananjay? Dhananjay,
Yes, ma'am. Yes, ma'am.
done?
Yes, ma'am. 88/7.
88/7. Oh, just let me check. Eighty-eight/7. Okay. Yes, correct answer, beta. Good. Suppose if you have given question like this, 1 upon 4 plus x square dx, and values are 0 to pi by 4. So how will you solve?
Ma'am, I'll try.
Have you remember this formula I have told you? That 1 upon x square plus a square is given. Then you will write 1 upon a tan inverse x upon a plus c. This formula here you will apply. Okay?
Ma'am, you solve it, ma'am.
Okay. Now say 4. You can write 4 as 2 square plus x square dx. Right, beta? Now by
Yes,
using this formula, the value of a is 2 na? So you will write 1 upon 8 means 1 upon 2. Tan inverse. X means x upon 2. 0 to pi by 4. Now put the values. 1 upon 2 is constant term. So you will write tan inverse pi by 4 minus tan 0. Now tell me the value of 10 pi by 4 is? 1045 is 1 na?
yes, ma'am.
Yes or no?
Yes, ma'am.
Yes, it will be 1. Wait. Here I have to write 1 instead of pi by 4. Then you will get the values. So 0 to 1, 0 to 1, 0 to 1. Now write 1 upon 2, tan inverse 1 minus tan inverse 0. Now value of tan is 1. At which angle? Pi by 4 beta. And 0 at 0 only. So you will write 1 by 2 pi by 4 multiply pi by 8 is the answer. Okay.
Yes, ma'am.
Please note this beta. Then I'm giving you next question. Written?
Yes,
Okay. Now see. Next question is from partial fraction. Suppose you have given limits 1 to 2, x upon x plus 1 and x plus 2. Evaluate it better. Now here you will use partial fractions.
yes, ma'am.
Use.
Ma'am, what should we write in like log 2 and log 3 like that?
Done, beta?
Ma'am, what should we write in place of log 3, log 4 those, ma'am?
Just you will write like this only, na? Log 2 or like log 4.
Yes, ma'am, I got minus log 3 plus 2
Hmm.
log 4 plus log 2 minus 2 log 3.
2 log 3. Okay, let me check then. First of all, I will solve it. X upon x plus 1 into x plus 2, beta.
Yes, ma'am.
Then it will be equal to a upon x plus 1 plus b upon x plus 2. Right, now after taking LCM, it will be a into x plus 2 into plus b into x plus 1. Right?
Yes, ma'am.
So now put x is equal to minus 2. Then it will be minus 2 is equal to b minus 2 plus 1. Then value of b will be 2.
Yes.
You got the same value?
Yes, ma'am, I got 2.
Okay. Now put x is equal to minus 1. Then minus 1 will be a into minus 1 plus 2. Then value of a will be minus 1, beta.
Yes, ma'am.
Okay. Now put. So it will be integrate 1 to 2. A means minus 1 upon x plus 1 dx plus 1 to 2. 2 is constant term. 1 upon x plus 2. Right? Then it will be minus log x plus 1. Right? Beta, limits 1 to 2 plus 2 log x plus 2. 1 to 2. You got same?
Yes, ma'am.
Okay. Now just put the values. So here you will put, this is minus sign. So you can write like this, log 2 plus 1 will be 3 minus log 1, log 2. Right, beta? Plus 2. Now put, it will be log 4 minus log 3. Have you got the same, beta? Dhanunjay?
Yes, ma'am.
Okay. Minus minus plus log 2 plus 2 log 4 minus 2 log 3. Now 2 log 3 and 2 log 3. It will be minus 3 log 3. I can write like this. Now this 2 will goes in power of 4 because log m raised to the power n, you can write n log m. Dhanunjay? Got it the same? Minus. Now you can write log 3 raised to the power 3 plus log 2 plus log 4 raised to the power 2. Now see beta, when these two are in addition, log m plus log n, it means they are in multiplication.
Yes,
So you
ma'am.
will write minus log 3 raised to the power 3 plus log 2 into 4 raised to the power 2. Can I write like this?
Yes.
Now this is in minus. So log m minus log n. You can write log m upon log n. Right?
Yeah. Yes, ma'am.
So it will be log 2 into 4 square upon 3 raised to the power 3. Then it will be log 2 into 4 square is 16 divided by 27. So answer will be log 32 upon 27. This is the answer. Clear?
Yes, ma'am. Clear.
I guess till here you have done this thing.
Yes, ma'am.
This
I have
step.
done so.
You have done till here, right?
No, ma'am. The above step.
Okay. Till here, right?
Yes, ma'am.
Okay. Now note these steps. And tomorrow we will start new chapter, Dhanunja. That is your binomial theorem. Okay.
Ma'am, did you complete the whole chapter integration or you
No,
left some?
not whole chapter, because we can't complete this whole chapter in 2 months, in 1 month only. We have got, we want so much time, na?
Yes, ma'am.
Yeah. I have just explained the important things. Okay, beta?
Yes, ma'am. Fine. Ma'am, till when are these classes?
Beta, I guess this week also classes will run.
Okay, ma'am.
Not sure, but na?
Okay, ma'am. So, ma'am, done.
Okay. So, Dhanunjay, I will share the questions, okay? Then try
Yeah,
to
ma'am.
solve. Okay?
Yes, ma'am.
Bye, beta.
Bye, ma'am. Have a nice day.
Same to you, beta.